In this video, we're going to be given a statement, and we want to write that statement as an inequality and then graph it on a number line. So let's look at the first one. So we're given the statement, you must be at least 18 years old to vote in the upcoming election, the presidential election. So this would look like X. If X is defined as the age that you can vote in the upcoming election, it's going to be X is greater than or equal to 18. We include 18 in our solution because 18-year-olds can vote in the election. So if you're 18 years or older, then you're eligible. So X is greater than or equal to 18. Now let's take a look at what it looks like on a number line. All right, we want to stick 18 in the middle. That's generally a good idea when we already have the inequality and we just want to graph it on a number line because we know something's going to go on at 18. All right, this goes in this direction. That goes in the positive direction. Okay, so at 18, we know we're going to include it because X can be equal to 18. So we're going to put a closed circle right at 18, and then we're going to shade everything to the right of 18 because we're looking for the solution of values, the interval of values that are bigger than 18, that are greater than 18. So we're shading everything to the right. And this is the solution interval graphed on a number line that answers the question, you must be at least 18 years old to vote in the upcoming election. So let's do a few more of these. Let's say water will freeze at temperatures of 32 degrees or less. Well, this is going to be where we know that they'll freeze at less than 32 degrees, but what goes on at 32? Well, it will freeze at 32 degrees or less, so we're going to include 32 in our solution interval. Any temperature 32 and less, water will freeze, so X is going to be less than or equal to 32. Let's go ahead and see what this looks like on a number line. Let's put 32 in the middle, since we already have our inequality, and we just need to write out a few terms just to see where the trend is going, and indeed that's the positive direction. And this is the negative direction. We should know by now that negative direction is the left, positive direction is right, but just so there's no ambiguity, we want to see just a kind of a trend here. So we label, we start with the number that's in question in our solution interval, and we just label a few terms on each side. Okay, so we're including 32 in our solution interval, so we're going to put a solid dot at 32, and we're looking for all the values that are less than or equal to 32. So we're going to shade everything to the left. And that's all there is to it. So let's look at a few more. Let's say the bank assesses an overdraft fee on all negative account balances. So we're looking for the set of all numbers that are less than 0. Okay, we're not going to include 0 in our solution interval because an account isn't charged if the balance is 0. It's only when it's a negative account balance. So on a number line, let's go ahead and draw our number line. Let's put 0 in the middle. 1 and 2. This keeps going. And then -1, -2, and this keeps going. Okay, so at 0, we're going to be left with an open circle right there. So we're not including 0 in our solution interval, so we're going to leave an open circle at 0. And we're looking for all the values that are less than 0, so we're going to shade all the values to the left. And this includes all the values that the bank will assess an overdraft fee, so we're just including all negative numbers. Okay, not a whole lot to these, we're just getting a visual representation of an inequality. Let's take a look at the next one. We're told a particular tire is deemed unsafe when inflated to over 80 psi, which is pounds per square inch. So X is going to be the psi where the tire is deemed unsafe. So we're going to say X is greater than 80. We can assume that the tire is unsafe or is safe at 80 psi and unsafe for anything over 80 psi. Okay, because we're not told anything about 80, so we're going to assume it's safe at 80. So let's go ahead and draw a number line showing this. We have 80 in the middle, 81, 82. This is actually very important to know because you'll be inflating your tires for quite a while. So x is greater than 80. So we're going to place an open circle at 80 because we're not including 80 in our solution interval. We're assuming that the tire is safe at 80 psi. It's unsafe for values of x greater than 80. So we're going to shade everything to the right, including all the values that are greater than 80. Okay, now notice the cool thing about inequalities is that we can actually turn this around and say that this particular tire is deemed safe when inflated to no more than 80 psi. So let's take a look at, let's see what this would look like. So the opposite of x is greater than 80, we could say is x is less than or equal to 80. If we define our variable x as the psi, the value of psi that is deemed unsafe for the tire, we can describe this variable x as the psi where the tire is safe, and that's at 80 or less than 80. So on a number line, let's see what that would look like. Just a little bit of extra work. It's really cool to think about this stuff. 81, 82, 79, 78. So let's see what's going on here. So in this first number line, we found the solution interval that satisfies all the psi where the tire is deemed unsafe. Well, here we're just redefining our variable as the values of psi where the tire is deemed safe. So what we're going to do is we're going to include 80 in our solution interval because x is less than or equal to 80, and we're going to shade everything to the left. So our tire is deemed safe at a psi of 80 or less. And this is really interesting because most real-world situations can actually be expressed both ways like this. It's all about how we define our variable. Okay, let's go ahead and do one more. Squeeze in one more down here. The maximum occupancy for a local restaurant is 120. So we're going to say that the maximum occupancy, or the occupancy, is legal for values of less than or equal to 120. Okay, we can't have more than 120 or the restaurant would probably be deemed a fire hazard or unsafe or something like that. So we can have no more than 120. So let's take a look at this. 120 is fine, more than 120 is not fine. So let's go ahead and graph this on a number line. 121, 122. And this basically means that the restaurant can have no more than 120 customers in the restaurant at a given time. We're including 120 in our solution interval because it's safe up to 120, so we're going to put a closed circle at 120, and it's less than or equal to, so we're going to shade everything to the left. So the restaurant's good to go as long as it has 120 or less customers in it. So we're graphing inequalities of real-world situations on a number line after we find the actual inequality, which we should be pretty familiar with now. These are actually pretty straightforward. All we need to remember is what's going on at the particular value. If it's equal to, if the value is actually included in the solution, we're going to put a closed circle. If it's excluded and it's just a less than or a greater than, we're actually going to exclude the value from our solution interval by placing an open circle there on the number line. So we'll actually get into actually solving inequalities in the next section, so we'll see you soon.